Alright, so today we're going to start working on adding rational expressions. The good news is you've been doing this for quite a few years. You've been adding fractions. You've been adding 3/4 plus 3/2. And those are expressions. Now their values, we're going to do algebraic expressions, slightly different, but the same way. So again, if I start with 3/4 plus 3/2, we look at 4 and 2, and we know the least common multiple is 4. So I will write 3/4 again, and I will make an equivalent fraction to 3/2 by multiplying top and bottom by 2. And I will write that here as 6/4. Alright, once the denominator is the same and only addition subtraction, you can write it here, 4, and you look at the top. You have 3 plus 6, which you notice I write. Now, on values, we know 3 and 6 are like terms. They're both dogs, they're both cats, whatever. And we get 9/4. But if I come over here at this point and I say, hey, let B be 4, let A be 3, and let C be 6. I can rewrite this expression as A over B plus C over B. Well, does it have a common denominator? Sure, it's B. And then it has the numerator, A plus C. But in this case, are A and C like terms right now? No. And this would be my answer. So as we work forward, we're going to work on rational expressions with variables. And I have two examples on the board. On the left side here, I have 4 over AX minus 6B over AX. We start by saying if we want to add them, are the denominators the same? The answer is yeah. So I write AX. In the numerator, then, I have to do the operation. 4 minus 6b, I write that here. Are 4 and negative 6b like terms? No. And that is the answer. That is as far as this will go. Now, the good thing is we've taken two terms that were a difference and we've made it one term. Very important for us as we go forward. On the other side here, I have 4 over a minus 6b over ax. Almost the same, except you notice there isn't like terms. And the question becomes, if I'm going to add these, I have to have a least common denominator. I have to have a common denominator, so I need the least common denominator, or the least common multiple of a and ax. Well, what I'm missing on the a is an x. So I multiply the top and bottom of the first term, and only the first term, by x, one of our algebra rules, and I get 4x over ax minus 6b over ax. The denominators are the same, thus we can write this. It doesn't matter if it's a sum or a difference in the bottom either. I have a over x plus y minus b over x plus y. When you see a sum or a difference, we treat it like one thing. Is there a common denominator? The answer is yeah. There's x plus y. So I write that in the bottom. Now what do I have on top? A minus b. Are these like terms? No. And so this is the answer. We won't have to do this for a while, but I want to be clear. If I have a over x minus b over x plus y, I can't add y. These are two different things. X plus y is one thing, and x is another. So literally, when I do this problem, the common denominator is x times x plus y. And you have to multiply by the sum on the first term and by the x on the second before you get a common denominator. X plus y is a sum, it's one hunk of junk. You can't just add y to top and bottom. So the answer to the right side is this. And there's nothing to do there, they're not like terms, you're done. There's nothing to cancel because this is a difference. Can't cancel unless it is factors, multiplication. A lot of times students will do junk like this. You cannot add to a fraction ever. And if you're not sure why, think of it this way. 2/3 is 2/3. If you multiply by 1 and 1 on top and bottom, it's still 2/3. But if you add 1 to top and bottom, 3/4 and 2/3 are not equivalent. Okay? We never add, we always multiply. So let's do a couple. Here's an expression, no equal sign, three terms, 4 over b, 1 over c, 1/2. The question becomes, what is the least common multiple of 2, B, and C. Well, I picked 3 primes. It is 2BC. So, I will have to change this. Now, I'm going to rewrite this, leaving space to do some work. Alright, the B needs a 2 and a C, so I multiply by 2C. Whatever I do to the bottom, I must do to the top. This needs a 2B, and this needs a BC. Now I'm going to rewrite this. 8C over 2BC plus 2B over 2BC plus BC over 2BC. And I want you to notice, and you won't have to do this as you get good at this, but I want you to notice that 4 over B is equivalent to this. If you do the cancellations, you don't want to. They're the same thing. And likewise, so are the next 2 terms. Again, the whole bottom is the same, so I can write it. Now I just have to write the numerator. 8C plus 2B plus BC. And the question becomes, are there any like terms in the numerator? No. Is there anything common in the numerator? Before you look at the bottom, C, B, nope, none of them are common. Nothing comes out. You cannot do any cancellation unless there's factors. Students sometimes want to cancel this BC and this BC. They're not the same. You have to have multiplication. Right now you have a sum. All right, just a few more examples. Over here, now I'm going to do a little faster, okay? We have X, B, and C. Again, 3 different variables, very easy to pick. The common denominator has to be XBC. Alright, so this needs a BC and a BC. So I get 5BC, plus this needs an XC and XC, so I have XBC on the bottom. And I have XXC, which we can write as X squared C. And on the last one, I need a B and an X. So I can write this as ABX over XBC. Now I suppose I could have wrote that as BCX or CXB or any combination of 3 because it doesn't matter what order. So I wrote it as XBC. I will leave it as XBC. Now the numerator becomes 5BC plus X squared C plus ABX. Nothing is common. Nothing can cancel. Often students want to try to make this smaller. There's no way to make it smaller. That is the solution. Now, the next one's a little trickier on the right side here. C3, C2, and there's a 1 under the 3. So what's the least common multiple? It is not C5 or C6. Again, I have 3 C's, 2 C's, no C's. I think I have to have 3 C's under each one, or C cubed. Because if I multiply this by C, and this by C cubed, and this by C cubed, and I rewrite this, notice how I get the same denominator, and it's the lowest power possible. And if I do this, then the answer is M plus BC plus 3C cubed, all over C cubed. Now, you notice there's nothing common. Nothing will cancel. The answer is done. If you accidentally go C5 here, what happens is you have C's in the top, and you'll be able to factor out and cancel. You'll be able to simplify. Alright, last 2. Alright, over here I have 2m, m squared plus 3. Alright, well, what's the least common multiple of 2m and m squared and 1? Well, 2m squared. Now, here's a trick I do. I actually write just the common denominator, 2m squared. Now, I don't have 2m squared here. I need a m. What I do to the bottom, I must do to the top. Here I have the m squared, but I don't have the 2, so I'll do that. And the last term I got a little bit more work. I don't have anything on the bottom, so I got to multiply by 2m squared, 2m squared. Now what do I have on top? I have xm minus 2y. 3 times 2 is 6, because you're multiplying m squared. I see if there's anything common, just to make sure I did it correctly. Xm, y, m squared. Nothing common. I am done. That is the answer. Now over here we have 4, 2, and q. And again, it's tough. This is 4q, not 8q. If you do 8q, you're going to have to factor. And this time I'll do it the other way. I'll say, hey, I got to get to the same denominator 3 times. Well, this needs a q. So I have pq over 4q, equivalent fractions. This needs a 2 and a q, which I'll write as 2aq. Again, equivalent fractions. And the last one I need just a 4. And again, these are all equivalent to the previous fractions. We don't want to cancel, but if we check them in our mind, we know they do cancel. Now, everything's the same on the bottom. So I say, hey, I can do this. And I get PQ minus 2AQ plus 4C. Nothing's common, thus I am finished. Keep practicing rational expressions. It's just like adding fractions.